This video is for Chapter 8, Lesson 3. And in this lesson, students will construct and analyze different representations of functions. Please get your materials ready and open your textbook to page 595. Vocabulary Startup. A linear function is a function whose graph is a line. So we have the word linear, and let's take it apart that the root word is line. So something that is linear has the form of or resembles a line. So it matches up. The everyday definition of a function is the purpose for which something is designed or exists. For example, a shoe, its function is to protect our foot while we're walking. Today we're going to be working with algebra functions, and they're going to tell us what to do or how to do things. What do you notice about this graph here is that it forms a straight line. The math definition of a function then is a relationship that assigns exactly one output value to one input value. Or, in our case, we're talking about x's and y's, which will create points that we can then connect to make a line. So in this lesson, we're going to be working on writing an equation to represent a function. In order to do this, the input, or the independent variable, will be represented by our x value, while the output, or the dependent variable, will be represented by our y value. We're going to be creating an equation that expresses how the dependent variable is in terms of the independent variable. So we talked about our function rules. Remember, we had our input, and then we had our output, and the rule is what affected it. Well, today we're going to remember that the input was our x value and the output was the y value. And we put in our information into a chart. And the left side was always represented by x, and the right side was represented by y. And we use that in lesson 1 to create ordered pairs. So what we're going to be doing is taking this rule and creating the rule based on what we're seeing here in the function table. So this is what they're asking us to do. We are going to write an equation to represent the function here in the table. And we're going to do that in relation to the x and the y. So there's a couple steps here, and it's not too hard, but we always start by looking at the output. Okay? And we want to find the difference. What is the change? How do we get from 9 to 18? Well, I know I can do that by adding 9. Then you check the next one. Sorry, that one's really messy. Let's try that again. I can do that by adding 9. To get from 9 to 18, I'd add 9. Well, that's also true when I go from 18 to 27, I add 9. So step 2 is find the difference between the outputs. Okay? This difference then becomes our multiplier. So the difference is our multiplier. So the change is by 9. So we're going to go up here and look at our input. If I put in 1 and take it times 9, do I get 9? Yes, we do. Let's look at the 2. If I take that times 9, I get 18. So once we find our multiplier, then you put the multiplier in front of x. So for example, we take our x and we are multiplying by 9, so I put 9x. So in order for us to find our output, the y, it will be y is equal to 9 times whatever the input, or x, is. So in a true equation, this 9 is called the coefficient, but we'll call it today the multiplier. Let's try another one. So they want us to write an equation to represent the function in the table. So I'm looking for my difference. I'm going to look here. How do I get from 16 to 32? Well, I would add 16. Now I'm going to check to get from 32 to 48. Do I add 16? Well, let's take 32 and add 16. Yep, it's true. It's an add 16. So 16 is now the multiplier. So let's check it up here. 1 times 16, do we get 16? Yes, we do. If we take 2 times 16, do we get 32? Yes, we do. So we start off by saying that the output, y, our bottom number, will be created by taking 16 times whatever input, or x, that we put in. So this is our equation, y is equal to 16x. Once we have found our linear, or our equation, then we can also turn this into a graph then. So now they would like us to graph a function. If the graph is a line, then the function is called a linear equation. And all the equations that we're going to be creating in this lesson will be true linears. So when you graph your points, you know that they should be able to be connected in one straight line. Then you know that you've done your work correctly. So in order to graph a function, the input is the x-coordinate and the output is the y, just like we did when we did our input-output table. Remember, the input always goes first, followed by the output, which we represent with x and y. And we did this in lesson 1 also. So let's take a look here. They've given us an equation, a linear equation. So then we get to make a table with ordered pairs, and you get to select any 3 values you want for x. So now what we will do is we're going to be creating a chart like this one so that we can come up with our ordered pairs. So let's start on our own instead of just looking at theirs. We need a column for our x. We'll put the rule in the middle, and then we'll have our y's. And from this, we will make our ordered pairs. So we'll put in an x value. The rule that they've told us is 2 times x, and that will give us our y. So keep it simple. Let's start with 0. So 2 times 0 is 0. So the ordered pair then is 0, 0. Try another one. Let's just go with 1. 2 times 1 is 2. So the ordered pair is 1, 2. Pick another number. Let's just do 2. 2 times 2 is 4. So the ordered pair would be 2, 4. So now they transfer these points onto the graph. Here's 0, 0. Here they did 1, 2. And here they did 2, 4. And I would want you to label the points on the graph and then connect them with a line. So you know this is a true linear function because we created a line. So let's try one for here. So they didn't give us a chart, so I'm going to start off by making my chart. The rule is x plus 1, and then we're going to get our y. So let's keep it simple. Let's go with 0. So 0 plus 1 is 1. So the first ordered pair is 0, 1. So let's go to our chart here, and I go to 0, and I go up 1, and put my first dot, or my point. Let's try another one. Let's try 1. 1 plus 1 is 2, so the next ordered pair would be 1, 2. Over 1, up 2, and there's my point. Let's take 2. 2 plus 1 is 3. So 2, 3 is my ordered pair. Go over 2, up 3, and there's our point. And I know I've done a good job because I was able to connect them in a straight line, so this is a linear function. Let's go ahead and have you try C on your own, make your own chart, and you can pause the recording or you can just follow along with me. So let's start off by making our chart. And our rule is 3x plus 2 to create our y. So let's start off with 0. So 3 times 0 plus 2. So using order of operations, 3 times 0 is 0 plus 2 is 2. So my ordered pair is 0, 2. And I'll go down and chart it right away. I'll go to 0, up 2. Now I'll try 1. 3 times 1 plus 2. Well, order of operations says 3 times 1 is 3, 3 plus 2 is 5. So my ordered pair is 1, 5. So I go over to 1 and up to 5. Now if you notice, if I go with 2, look at the distance, the gap I'm getting between my first and my second point, the red and the blue dot. I'm probably going to be off the graph, and that's just fine. We can go ahead and do that and just plot the point up kind of in the air. If we pick 2, we're going to do 3 times 2 plus 2, and we get 3 times 2 is 6 plus 2 is 8. So the point is 2, 8. So I can go over to 2, and here's my 5. I'll have 6 is right on that line, so it's going to be about right up here. Probably not perfectly, maybe up a little bit more to the side. And then I will connect it with a line as best I can. And sometimes you're going to have to do that. You're going to have to maybe float a dot up in the air. That's another reason that I would suggest that when you're picking your points, your x values, keep them small and close together so that you don't have gaps all over. I could pick 10, but look at my chart on my graph. I only go up to 5s, so choosing a 10 would be way over here, and that just won't be helpful for us. Let's check this out, how it works with a story problem. Martino constructed the graph shown, which shows the height of his cactus plants after several years of growth. Make a function table for the input-output. So what they went ahead and did is that they picked 3 input values of 1, 2, and 3, and they said that the corresponding output values were 42, 44, and 46, which they put in the chart. So then they asked us to graph that. So they created their ordered pairs. The first one would be 1, 42. The next one was 2, 44. And the next one was 3, 46. And so then they went ahead and graphed it. They went over 1 up to 42. They went from 2 up to 44. And from 3 up to 46. And then they connected it with the blue straight line because it's linear. So now we're going to add an extra twist. They would like us to write an equation from this graph to show the height y of the cactus after x amount of years. So when we look at this, again, when we have the charts, we look at the output side first. How are we changing from 42 to 44? We add 2. And when we go from 46 to 44, we add 2. So this tells us that 2 is our multiplier, or the coefficient. So we're going to take 2 times x. All right, so y will be equal to 2 times x. Now, we've got a little bit of a change here, something a little bit different, in that then I always asked you to go up to the input and say that you do it times 2. Do you get 2? 1 times 2 is 2, but look, my answer is actually 42. And if I checked it here, 2 times 2 gives me 4, but that does not give me 44. So this tells you that there's a second step to your equation. That, yes, we're multiplying by 2, but what's the difference? If I multiply 1 times 2, I get 2. How do I get up to 42? Well, I would take 2 plus 40. And on the second one, 2 times 2 is 4. So how do I get to 44? I'd have to add 40. And this pattern will continue. So we're going to add to our equation and say that it's y is equal to 2x plus 40 more. And this will happen on some of our equations. It won't be just simply finding the multiplier. We're going to actually have to do a second step about adding a number or subtracting. So let's give it a try here. Put it all together. Here they would like us to fill out and find out the total amount y that you spend on one book and x on magazines. Make a function table for the input and output values. And you notice that it's empty right now. We're going to fill in the function table. In order for us to do that, we're going to look at over here in our chart graph. So if we go ahead and label on our graph that this first point here would be at 1, 20, that's our input. The x is 1 and the y will be 20. Looking at our second point, it's at 225. So that's our second ordered pair, and we'll put it right into the chart. The next one is at 330. So that's our next ordered pair. And the last one is at 435. So our main goal is that we made the function table. Check, we've got that done. Now we need to write the equation to find out what's going on. So y is going to equal, we need to figure that out. So again, I look at my y's, my outputs. How do I get from 20 to 5? I'd add 5. From 25 to 30, add 5. So my multiplier is 5, so I put that next to my x. So I check my work over here with my inputs. 1 times 5 is 5, but that doesn't give me my answer of 20. So that tells me I have to take and put 5 plus what is 20, and that would be 15. Let's see if it works on the next one. 2 times 5 is 10. If I add 15, do I get 25? Yes. So our equation is 5x plus 15 more. So go ahead and go to your gold card and find your practice assignment. If something's not clear, be sure you come and ask me and look at your notes carefully and to help you. Otherwise, good luck.